Is this proof of the existence of another universe? For over 2 years now, the James Webb Telescope has been homing in on the deepest secrets of the cosmos, and it has already detected a whole range of structures that, according to our understanding, should not exist in this form. Where our current models have reached their limits, a theory finally comes into play with the British physicist and Nobel Prize winner Roger Penrose as its most famous advocate. According to Penrose, the Big Bang was not the beginning of everything, but merely the explosive transition between two cosmic chapters. In fact, Penrose is convinced that the universe has always been subject to a fixed cycle of destruction and rebirth. Amazingly, the latest discoveries now even suggest that he is right. But what about the mysterious Hawking points, which, according to Penrose, embody the remnants of a previous cosmos? Infinity is limited, at least for us. Although quite a few experts suspect that the universe is infinite, from our earthly point of view, we are only able to see an infinitesimally small fraction of the whole. Our spherical field of vision is appropriately referred to as the observable universe, and it encompasses the area from which information could have reached Earth since the Big Bang. Given that the cosmic birth took place 13.8 billion years ago, one might think that the distance to our natural line of sight, the so-called event horizon, is also 13.8 billion light-years. But that's not true. After all, the cosmos, or space, has been continuously expanding since the beginning of time, which means that distances already covered have been lengthened retrospectively. The distance to the observation horizon is ultimately estimated at 46.3 billion light-years. What is exciting here is the fact that every point in the universe has its own observable universe. In other words, if there is a civilization billions of light-years away out there, it can see a part of space that will forever remain the great unknown to us. As a result of these cosmic blinkers, experts can only speculate about what lies dormant outside our field of vision. While many researchers believe that the structures there correspond to those in the local universe, others estimate that the invisible depths of space are much more bizarre than we can even imagine. However, the black hole that the James Webb Telescope added to the star charts a few weeks ago was also much more bizarre than we could have imagined. Christened with the scientific name Li 568, this gravity monster had already existed for 1.5 billion years after the Big Bang. Despite this, it apparently devoured matter 40 times faster than is theoretically possible. But let's be clear. This mysterious Webb discovery by no means marks an astronomical exception, but rather corresponds to a new, confusing pattern. We now know of a whole series of black holes that simply appear far too massive for their early formation. These include the quasar, an active galactic nucleus called J120+0641, which dates from the cosmic twilight era but already weighs over 1 billion solar masses. To the researchers' dismay, however, a closer examination with Webb's mid-infrared instrument failed to reveal any extraordinary feeding mechanism. It turns out that we simply don't know how a supermassive black hole could have been fully mature when the cosmos was only 5% of its present age. Since our current models can no longer explain these cosmic premature babies of the observable universe, new approaches must be taken into consideration. The fact that these sometimes have the potential to revolutionize our understanding of the universe is demonstrated by Sophie Kidman's remarks. When asked whether the surprisingly massive black holes could have formed from structures that existed even before the Big Bang, the astrophysicist from the University of Cambridge replied that the exciting thing about this question is that nothing is ruled out. Some people say that the massive black holes we now find in the early universe must have been formed by a direct collapse. There are several publications suggesting that the observations prove this. If black holes grow efficiently, they have just enough time to develop from a very light seed. Although Kudmany emphasizes that this model is just one of many explanations, it comes with a groundbreaking premise. There actually was something before the Big Bang. The cyclic model, which proposes that the end is a beginning, suggests this possibility. The fact that current cosmology has reached its limits in many respects is also demonstrated by the Webb discovery that triggered an astronomical crisis in the first place. As early as February 2023, news had already spread that there were 6 impossible galaxies out there as massive as the Milky Way today, existing 13 billion years ago. This unexpected finding starkly contradicted our theories about the density of matter in the early cosmos and about galaxy evolution. These inexplicable objects quickly earned the nickname universe breakers. Apparently, some galaxies in the young universe were much more efficient at converting gas into stars than others. At least, that was the conclusion reached by a research team from the University of Geneva, who studied 3 galactic heavyweights also known as the red monsters because of their appearance in Webb images. According to our theories, galaxies form relatively slowly within halos of dark matter. These capture atoms and molecules and bind structures around them with their gravity, from which galaxies ultimately develop. But while, as a rule, only about 20% or less of the captured gas is converted into stars, the corresponding proportion in the case of the red monsters is a whopping 50%. Once again, how the structures managed this some 1 billion years after the Big Bang remains an unsolved mystery in astronomy. For the time being, all we know for sure is that something must have happened in the earliest cosmic chapters that paved the way for the astonishing growth of galaxies. But what if that's not true? In other words, what if the foundation for the development of the universe was not laid with the Big Bang but before it? Then we would have arrived at the core of an astonishing theory that Roger Penrose has been putting forward for quite some time. Honored with the Nobel Prize in Physics in 2020 for his research on black holes, the British mathematician and physicist is convinced that the universe is cyclical. Consequently, Penrose does not see the Big Bang as the often cited beginning of literally everything, but merely as the transition between 2 eons of cosmic life. True to the motto, every end is followed by a new beginning, the universe, according to Penrose, would continue to expand until all matter has disintegrated and become light. This extreme environment, in which nothing has a time or space reference to one another, will inevitably lead to a new Big Bang over and over again. As part of each cosmic finale, the black holes will also evaporate completely, immortalizing themselves in the following universe in the form of a special remnant that testifies to the existence of the previous cosmos. But that's not all. Penrose claims to have found exactly these telltale traces in the cosmic microwave background. In detail, this refers to numerous circular spots that can be seen in both the Planck and WMAP satellite data. Just to clarify, the cosmic microwave background radiation, or CMB for short, is a relic from the early days of the universe, created around 380,000 years after the Big Bang during the recombination epoch and still permeating the entire universe today. To understand why the discovery of so-called Hawking points could be so significant, we must first realize that the cyclic model posits cosmological inflation before the Big Bang. This generally refers to a phase of extremely rapid expansion of the cosmos, during which the universe experienced an unparalleled growth spurt immediately after its creation. But if we now place this inflationary growth before the birth of the universe, we are dealing with the result of the exponentially expanding future of an earlier eon. In principle, the adjustment from eon to eon is sound from both a mathematical and physical point of view. However, supermassive black holes represent an exception, as these would have almost completely absorbed the galaxy clusters in their environment by the end of a cosmic chapter. Before they themselves completely evaporate into Hawking radiation, they would take the entire radiated energy with them into the subsequent universe in the form of a single Hawking point. The photons produced in this process would, in turn, be found in an expanding region, which, however, only becomes visible when it finally appears in the microwave background radiation of the new cosmos. On paper, such a Hawking point would look like a disk the diameter of the full moon. In practice, the data mentioned have revealed exactly that in the microwave background. To be more precise, the ominous spots correspond to multiples of the average CMB temperature fluctuations. In fact, experts had assumed that such features would have been completely wiped out by cosmological inflation. In view of this exciting discovery and all the cosmological inconsistencies uncovered by the James Webb Telescope, is it possible that our world does not correspond to the one universe at all, but only to the current cycle? Well, that is precisely the focus of the astronomical debate, which is far from over. But even if the cosmos really is subject to an eternal cycle of destruction and rebirth, some fundamental questions remain unanswered. What, then, marked the starting point of the cycle? Is there such a thing as a starting point in eternity at all? And will mankind one day succeed in fully understanding the world in which it lives? Well, who knows?